Hello everyone, welcome to the next lecture on the MCQ of Eigen's value. Today we will discuss about all those previous year questions from the year 9 to 13. This is the part 2 of this Eigen value. Myself Dr. Garg. You can simply follow my YouTube channel Dr. Harish Garg. Else you can simply scan and join my WhatsApp group for more updated videos. What we have discussed in our previous part, that is a part 1, we have discussed 30 questions of the previous years from the year 9 to 23. Now in this lecture we will describe the more than 33 questions in this part 2. We are trying to explain all the questions with the help of the shortcut tricks related to the Eigen's value. So let's start with this one. So if A is an n cross n matrix having the rank of matrix A is R, V is the vector space and it consists of all those matrices from the n cross n such that Ax is equal to 0. This is given to you and your target is to find the dimension of the n. That's very simple. How you can find the dimension of the n? Firstly, you can think about that. This is nothing but my kernel of the V. Collection of all those kernel of the A. Then how you can find that dimension of the V? Very simple. You have to find how many columns of the X. So this is my number of the columns. You can write as a n. Multiply dimension of this. How you can find the dimension of the kernel? N minus rank of the matrix A. So what is the rank of the matrix A? Is R. So the right answer is of this. So n square minus nr is the right answer of the problem. Okay, look about this one. It is a 3 cross 3 matrix. So remember always, this is the always remember, the trace of the matrix is always be the sum of the Eigen's value and the determinant of the matrix is the product of the Eigen's value. So that is the concept we will use in all these questions. So there are the 3 Eigen's value of the 3 cross 3 such that A plus I of is 0. So if I compare this equation with here, what is the lambda? Minus of I. So it means minus of iota is the eigenvalue of this matrix A. Since it's a complex number, it always occurs in the pair. So plus iota is also the eigenvalue. Determinant of matrix A is 3. So the product of the eigenvalue is my 3. So what is the meaning of that? So it's a minus iota square of this third eigenvalue is 3. So what is the meaning of that? It is my here. These are the Eigen's values of the A. What are the Eigen's value of the A square? So it will be the minus iota square. So minus 1 iota square 9. You find the trace. Trace is the sum of the Eigen's value. So minus 1, 9. The trace is my 7 is the right answer of this product. Next one is if 2 is the eigenvalue of the matrix A, it means A minus of 2 lambda is my 0. It's a 2 cross 2. So the one of the eigenvalue is my 2. The other eigenvalues, you have to find the rank of the matrix A minus. So what is the meaning of that? If we know that if determinant of A is 0, what is the meaning of that? Rank of A is less than of the dimension of the matrix. If A is n cross n. So here it is a 2 cross 2. So the rank of A minus 2i is less than of 2. So meaning of that is 1 is the right answer. That's a very simple concept. Okay, A is a 4 cross 4. So it has a 4 Eigen's value. The trace of the A, you can write as a trace of A plus trace of B. So what is the trace of A? These are the Eigen's value. Minus 1, plus 1, plus 1, minus of 2. The trace of A is the sum of the Eigen's value. So what is the sum of the Eigen's value will be? Minus 1. These are Eigen's value of the A. How you can find the Eigen's value of the B? There are again 4 values. When A is minus 1, so its value will be plus 1, minus 5, plus 1. Is a plus 1. When lambda is 1, again you can substitute here. It is again plus 1. When it is 1, again it's a plus 1. When it is minus of 2, that's a minus 2 raised to power 4, minus 2 raised to power 2 plus 5. So 16, 20 plus 5. So it is a 1. So what is the trace of this? 4. So right answer is my 3 is the correct answer. Okay. A is a 3 cross 3, so it has a 3 Eigen's value such that M transpose of this is equal to 6 minus 3 0. How you can find the eigen's value? So we all know this is the property of the eigenvalue or definition, where this is my eigenvalue. What is the x? X is my eigen vector. So how you can see that? I can write this number in terms of -2, 1, 0. So what will be here? I can written as a minus of 3. So clearly say that it is my of this nature. So what is the eigenvalue of this? -3 is my eigenvalue of the m. Now we need a m cube. So what is the eigenvalue of the m cube? -27 is the eigenvalue of the m cube. So it means if I write this number as 1, -1, 0, it will be alpha, beta and gamma. Fine. So I have to write this number as 1, -1/2, 0. One of the eigenvalues is -27. So it means here is a 1. So what is the value of the alpha? It should be a minus of 27. That's why it will be alpha. So what is the meaning of that? What is the mode of alpha? It's a plus of 27 is the right answer of the problem. Okay, A is my 4x4 matrix. So it has the 4 eigenvalues. 0 is the eigenvalue of this. With the algebraic multiplicity is 0. So 2 eigenvalues are 0. We all know, so what is the determinant of this eigenvalue? It will be 0. When the determinant of this matrix will be 0? Clearly says that when A will be 0. So all this option has a 0. Now the other are B 0 or B non-zero. So if I write here as A minus of lambda I, what will happen? So it will be minus of this 0, 0, A is my 0, -1, 0, 0, 0 and B, 0, -1, C, 0, 0, -1 of this. Fine. Now you can expand them. It will be my lambda. So I can write written here. So I can expand corresponding to this. Now this is the matrix. I can expand here. So it will be minus of this. So it is minus plus C. It will be a 0 plus B of +1. Now it has the 2 0 eigenvalue. It means definitely the characteristics equation must be of this nature. So it means when it will be here, when this part will be 0, when B will be 0, because once B will be 0, it will be my here C minus of this plus of here. So clearly say that it has a 2 eigenvalue as a 0, 0, and you can find the roots, but B is a 0. So B is a non-zero, cancel out, B non-zero, cancel out, cancel out. Right answer is my, here is the right answer. Okay, if omega is a complex root such that here, then you have to find. Okay, so we all know this value will be 0. Now if you add them in the row wise, it will be 0, 0, 0. So what is the determinant of this? 0. So A is invertible, not possible. Rank of A is 2 because the rank of this is 0. So it will be less than of the 3 here. 0 is one of the eigenvalue, that's correct. There exists a linearly independent vector such that this of this. I think that's a very simple. V is a complex number, so I can simply take iota, iota, iota. So what will happen of the AV? This of here. So it will be iota times 0, iota times 0, because 1 plus omega square is 0. So this is satisfied. So one number belongs to this. Similarly, you can take as a minus iota, minus iota, minus iota. So this is also the correct answer. B, C, D are the correct options. Okay, so A is a 3 cross 3 matrix such that, so it has a 3 eigenvalues. Determinant of them is 2. One of the eigenvalues is my here. You have to find the other values. Okay, so these are the complex number. What are the eigenvalues of this? So we all know the complex number always occur in the pair. So you can see, are they occur in the pair? No. So this option cancel out. Are they occurring in the pair? No. This option cancel out. Again 1 plus 1. What is the complex conjugate of this? It is minus iota minus 1. So this is also cancel out. What is the complex conjugate of this here? So I can written as this is the complex occurring at the pair. So this is the only right answer of this problem. Moreover, another way is how you can think about that as 1 is the eigenvalue of the A. So what is the eigenvalue of the a square? Also 1. So if a square minus 2 has the eigenvalue of this, then what is the eigenvalue of the a square? I can take as a 2, addition on the both side, this 2 minus plus of 2 minus of 2 plus of 2. So what is the meaning of that? 1. It will be 2 iota, it will be the minus of 2 iota. You can see 1 is the eigenvalue of a square, correct. But if you look about this option, if I add plus 2 on the both sides, so it will be the 3. So option is cancelled. It will be 3 cancel out. It will be 1, but it will not be occurring in the pair. So the right answer of this problem is D. Okay, so M is my here. Find the matrix P such that this becomes a diagonal matrix. So how you can find the matrix P? What is the property of the P? How you can construct the P? What are the columns? These columns represents eigen vectors. Fine, and they are linearly independent. So they are the linearly independent eigenvector. So if I consider this is my eigenvector, so what is the meaning of that? If I consider this of here, if I able to find this one, then it will be the right answer. So if I multiply them, what will happen of this? It will be minus 1, because first and third component, so it will be 0, it will be minus 1. So can I write this as? Yes, I can take minus 1 as a common. So the first pair is satisfied. You can think about the second pair. If I multiply this by M111, so it will be my minus 1, it will be my minus 1, it will be my minus 1. Can I written as a 1, 1, 1? Yes. So minus 1 is the array. Similarly for the third component, 1, 1, 0. That is the first and second. So it will be my 2, 2, 0. Again I can written as 1, 1, 0. So it means this is the right answer. So since only one correct option is there. So what are Eigen's values? These are the Eigen's values. I can check you for the second part. What will happen? Say you can see this. So minus 1 and 1. So it is a minus 1 and plus 1. So it will be my minus 5. Minus 1, it's a minus 6. It will be my plus 1. Can you return this in the terms of minus 1, 0, plus 1? You can't return them. It means this option is cancelled out. Similarly for here, similarly for here. So this is the only right answer of this problem. Okay, so A, X and Y are here. This will be, then you must have trace of A is not equal to 0. What is the trace of A? This is my 2x. Sorry, yes, trace of A is that sum of the diagonal, sum of the Eigen's values be. So what is the eigenvalues of this? You can see minus trace of A is my 2x of this plus x square plus y square. So what is the trace of A? That is a 2x. It can be 0 because x belongs to a real number. So it means this option is cancelled out. A transpose is A inverse. So we can see. So x inverse is 1. So it means here plus 1 here. So you can see lambda will be my, you can find the two distinct eigenvalue. Clearly says that you can find the two distinct eigenvalues here. And if I chase x as say my cos theta, y as my sin theta, then it will be my cos theta plus minus iota sin theta. It means the Eigen's values are e raised to power this, e raised to power minus of this. So both are the distinct. So it means A, determinant of A is a non-zero, so A inverse exists. And you can see what is the A transpose of this. A transpose of this is x minus y, y and x, because x square plus y square is 1. So this option is correct. Because all are my distinct eigenvalues. So if it is a distinct eigenvalue, what is the meaning of that? This is my, this matrix is my diagonalization. So I can write this number as of here. So this, so both are my, this is the diagonal matrix over the complex field. So this is the diagonal matrix over the complex field. Now look over the last option, whether it's a correct or wrong. A of, so firstly you can take n as a 1. So if n as a 1, x is my cos theta, y is sin theta. So this is x, y, minus y, x. It's satisfied. What is my a square? So if it is my a square means here. So if I take, if I simply take it as a x minus y, y, x, y, x and minus y. And it will be x square minus y square. it will be my 2xy minus 2xy x square. This is a minus y square. Now clearly say that it's satisfied, because if x is my n is my 2, so what is the meaning of the x square minus y square from here? Cos square minus sine square. So what is the meaning of that? Cos of 2 theta. So it will be this number is my cos theta, this is cos theta, this is 2 sine A sine B, 2 sine A cos B sine 2A. So this option is also correct answer, this problem. So B, C, D are the right answer. Okay, so these are the 4x4 matrix. Eigens values are my here. B is this, then you have to find this. These are the eigens value of the A. You can find the eigens values of the B. When it is minus 1, it will be 1, minus 5, plus 5. It's a plus 1. When it is plus 1, again it's a plus 1. When it is 2, so 16, 20, plus 5, 1. When it is 3, 81, it's a 9, 545, plus 5. So this is my 40. So it is my 41. Then what is the trace of A? This is plus trace of B. So this the trace will be my 5. It will be 3. It is 40. So it can never be 0. Determinant of B is 1, because you can see the product is not equal to 1. So it means this option is also cancelled. Trace of A minus trace of B. So what is that? 44. Again the determinant is not 0. So trace of A, again it will not be 0. So I have to check the calculation of the trace of B. So what is that? It will be 1, 1. So it's 2, 4, 20, 5, 1. So it is 3 raised to power 4. So it's 81. 3 raised to power 2, 9, 45 plus 5. So it's a minus 40 plus 41. So none of the correct answer is there. So that is a none of above is the, none of this is the right answer, because none of them is satisfied as a here. Okay, so again A is a 3 cross 3. Determinant of them will be my 6. Trace will be 0. Determinant of A plus I is 0. I can see, I can compare them. So what is the lambda? Is my minus 1. Minus 1 is the one of the eigenvalue. This is cancel out, rest are there. Determinant is my 6. This is minus 6, cancel out. This is plus 6, this is plus 6. Trace will be 0. Trace will not be 0. Trace is a 0. So the right answer is my D is the correct answer. Okay, so again it has a 3 eigenvalue, 1, minus 1, 3. It has the A has the eigenvalue. We need A square. So what is the A square eigenvalue? 1, 1, 9. Then A square plus A, it is 2, 0, 12. So determinant of this will be a 0. So it is a singular. So this option is cancelled out. A square minus A. So what is the A square? Minus of A, 0, 2, 6. Again it's a 0. Determinant of this will be a 0. So it's a here. A square plus 3A. So I can multiply by 3A. So it's a 4. Then minus of 2. Then it's 9 plus 6, 15. So clearly says that the determinant is a non-zero. So it's a non-singular. A square minus of 3A. So 1 minus 3. 1 plus 3. 9 minus 6. Again its determinant is non-zero. So both are the correct answer of this problem. Okay, so are the eigens values of this. So you can find the eigens value of this. Lambda square minus trace. Trace is my 1. Determinant will be 1. So I can solve this number. 1 plus minus root 5 over, sorry, it's a minus 1. 0 minus 1. So 4 minus 1 over 2. So one of the eigenvalue is say alpha. 1 plus root 5 by 2. Other number is my 1 minus root 5 by 2. Now alpha n and beta n denotes the eigenvalue of a raised to power n. So what is the eigenvalue of this? Here, this will be here, such that alpha n is greater than of beta n. So this is my alpha n, this is my beta n. Now I think that's a very simple. Clearly says that 1 plus root 5 over 2 is greater than 1. 1 minus root 5 over 2 is less than 1, or even it's a negative. Then when you take as n approaches infinity, this number is positive, so it goes to the infinite. So this option is correct. And since this number is my less than 1, so when it goes to the infinity, it goes to my 0. This is correct option. When beta n, now look about this option. When n is my odd, when n is my odd, that is n is 1. So this number is 1 minus root 5 over 2. So root 5 is my 2 point something. So it becomes my less than 0. That's a negative. So when n is 1, it's a negative. Oh, sorry, n is 1, n is odd, it's a negative. So n is positive. So right answer is A, B and D are my correct options. Next one is P and Q are my square matrix such that PQ is my identity matrix. Then 0 is the eigenvalue of this. I think again a very simple. What are the eigenvalues of this? Eigenvalue of identity matrix 1, 1, 1, which is a non-zero. So it means the determinant of I is non-zero. So the determinant of PQ must be a non-zero. So when it will be the non-zero? When 0 is not, because if 0 is the eigenvalue of P, then determinant will be 0, so cancel out. So neither is the right answer of this problem. That's a very simple concept. Okay, so now that's a major question about that. If M is my 3 cross 3, eigenvalues are 2, 0, 2 and A. So 0 is the eigenvalue. It means that determinant of this M will be my 0. V, U and here. Okay, fine. So firstly we will check about that. Firstly we will check about this portion. What is a V plus W? So this is my W. So what is a V plus W? Is a 0, is my 3, it's my 1. So is it possible? Yes, you can see I can take as a how can I take that? I can take 2 as a common, so it is 3 by 2, it's a 1 by 2 because 2 is the one of the eigenvalue. So there exists a M. Yes, it's a correct option. So this option is cancelled out. Now there are the 3 options are there. Okay, look about this option. D is a span of the U, V and W. U, V and W. So what is a span? Is linear combination of this U, V and W. That is alpha 1 U, alpha 2 V, alpha 3 W. Okay, so if you look about that, what is the eigenvalue of the determinant of them is a 0. What is the rank of the M is 2. Fine. So we all knows when it will be the solution. When rank of the M condition B, both must be same and it should be less than of M, because the rank of them is a 2, so it will be less than of the 3. What is the span of this? If you look about this, if I just prove that there exists a matrix D whose rank is not equal, then it has no solution. If I consider any of the matrix D whose last element is a non-zero, is it possible? D is a span of this. So you can see if I take the linear combination of this, since there is a 1, so definitely I can consider any of the matrix whose last element will be a non-zero. So what is the meaning of that? Rank of M is my 2, rank of the M by condition will be 3, which is not equal to 0, has a no solution. So third option is cancel out. So this option is cancel out. This option only 2. So this option is cancel out. This, now there are the only 2 correct options. What is the trace of here? So eigenvalues has 2A and A square. What is the trace of this eigenvalue of the M? What is the eigenvalue of the M square? 0, 4, A square. Then what is the trace of this? 0. Trace of this will be 8 plus A square plus of 2A. So clearly say that it will not be 8. So the right answer is cancel out. So fourth is also cancel. This is the correct option all. Although there is a need to prove that, but since there is only one option remaining that, so that's the right answer of this problem. Why A can never be 0? Because here if A will be 0, then 0 is the multiplicity 2, but here it is not mentioned that 0 has a multiplicity 2. So the right answer is my 1 and 2 are the correct options. Fine, look at the last one. No, not the last one. Sum and the product of the eigenvalue. What is the meaning of the sum? Trace of the matrix A. Product is my determinant of this. What is the trace? a plus b plus 3 is my 10. Determinant of the eigen's value is my 30. So what is the determinant of this? You can see it's a lower triangular matrix here. So what is the a plus b? 7. ab is my 10. Then what will be the a square plus b square? So you can simply use this formula. A square plus b square plus of 2ab. Now you can substitute here. It's a 49. This we need to ones, and this is 20. So what is the answer of this? 29 is the right answer. Okay, M has the 6 eigens value. 2 and minus 1 are the 2 eigens values. Then which of the following are there? So if these are the eigens values of the M, what are the eigens values of the M raised to power 5? 32, minus 1, and so on. So I can substitute here. 32, A, B has the eigenvalue 2B. When it is minus 1, it is my A plus B has the eigenvalue minus 1. So can you solve this one? You can see that if this is my A, this is my B. A minus B minus 1. A will be 10 plus 22. It's my 32. That's the correct answer. Here, this is my A, this is my B. So A minus B minus 11 minus 10 is not equal to minus 1. Cancel out. Minus 10 minus 11 not equal to minus 1. 10 minus minus plus 11 not equal to 1. So the right answer is only A. Okay, next one is there are the 2 eigens values, 2 cross 2. There are the 2 eigens values are here. So what is the trace of this? Trace is my 4. A will be my 2. Determinant of A will be 2. So the right answer is A. So A here is 1, cancel out. A 2, A minus 1 cancel out. A minus 2 cancel out. Right answer is my here. How you can find? You can see the determinant 2A minus B square is eigenvalue product here. A is my 2. So 4 minus B square is 3. So B is my plus minus 1. But there is no need to solve this because there is only one correct option from the here. Okay, which of the following is the eigenvector? So whenever there is eigenvector, we have always used this concept. So what is the A? 7, 2, 3, 2. Which of the following is there? So I have to multiply this and we will get 8 times something. So let's start with this first option. 3, 2. What is the answer of this is? 21 plus 6, 27. 6 plus 4, 10. Which is not equal to 8 times of this. So this option is cancelled out. Look about the second option. If it is 3 and minus 1, it will be 21 minus 3. It's 18. 6 minus 2, 4. Can you write this in terms of 8 times of 3 minus 1? No. This option is also cancelled out. Now look about this next option, minus 1, 2. So it's a minus 7 plus 6. Minus 7 plus 6 is a minus of 1. Minus 2 plus 4, it's a plus of 2. Again, it can never be written as 8 times of this. So right answer is here. We can check that. If I check here, it will be 1 and 2. So what is the meaning of that? 7 plus 6. 7 plus 6, 13. 2 plus 4, 6. Again, it is not be there. So is there any mistake? We can check about the first option again. 2, 2, 3 and 2. So it's a 21 plus 6. 21 plus 6 is a 27. 6 plus 4, 10, which is not written as 3, 2 of this. So definitely not be there. If it is 3 and minus 1, so it's a 21 minus 3. 21 minus 3 is a 18. 6 minus 2 is a 4, which is not written as 3 of minus 1. Minus 1, 2. So it means none of these is the right answer of this problem. Okay, V is the vector space of the polynomial degree at the most 2. V is the vector space sum of the eigens values. Sum of the eigens value. What is the sum of the eigenvalue? That is a trace. So we have to find the trace. P is the polynomial of degree at the most 2. So P is x, x. These are my basis. These are my basis of this. So when I substitute this P in here, what is the first answer? P of 0 is 1. 1 minus 1, 0. 1 plus 1, 2. 0 is 1x square. Now when p is equal to x is a 0 minus 1 is a minus 1, 0 plus 1 plus 1, 0 x square. When p is equal to x square, it will be 0 square minus 1 square is a minus 1. P of 0 is 0, 0 plus 1 is 1, p of 0 is 0 here. So I can write as a matrix 0, 2, 1, minus 1, 1, 0, minus 1, 1, 0. So what will be the trace? Sum of the Eigen's value. That is 1 is the right answer of this problem. Okay, which of the following is the diagonalizable? So how you can check the matrix is diagonalizable? There are the two rules. If Eigen's values are distinct and if eigenvalues are not distinct, then arithmetic, algebraic multiplicity and geometric multiplicity must be same. So let's start with this one. So what are the equation? Lambda square minus of 2 plus of 0. So what are the Eigen's value? 0 and 2 which are distinct. So it is this matrix is my diagonal, but we need not. So this option is cancelled out. We can write the trace minus 5, 4 plus 2, 6. So Eigen's values are my 3 and 2 which is distinct. So it is a diagonalizable but it is not be there. What are Eigen's values of this? 2, 3 and 2 because it's a diagonal matrix. Here is 2, 3, 3. Now they are not same. So I have to use this concept. Since 2 repeated 2 times, so algebraic multiplicity of 2 is my 2. In this case, algebraic multiplicity of 3 is my 2. So let's start with this one. So how you can find the geometric multiplicity? That is a dimension of kernel of A minus lambda I. That's over. How you can find the kernel dimension of this? N minus dimension of the A minus. This is the geometric multiplicity. So let's see. Firstly we can find here. So I can find A minus rank of A minus 3i. If I found that A minus 3i, it will be minus 1, 0, 0. What is the rank of this? Rank of this is my 2. N is my 3. Rank is my 2. It is a 1. But algebraic multiplicity is 2. Geometric multiplicity of this is 1, which is not equal. So it is not a diagonal. So it's the right answer is here. If you look about this example, then it will be 3 minus rank of A minus 2i. If I take A minus 2i, 0, 1, 0. What is the, what is that? If A minus of 2i, so it's a 0, it's a 1, it's a 0. So what is the rank of this? Rank of this is 1. So geometric multiplicity of this is 2, which is same. So it is a diagonalizable, but we need a not. So the right answer is my third is the correct answer. Okay. A is my 2 cross 2, determinant is 1, trace is 2. So I can write this as trace of this plus determinant of A. Trace is my 3, determinant is 1. So what are the Eigen's values of this? So I can say 1 plus minus 9 minus 4 over 2. So it is 1 plus minus root 5 over 2. So one eigenvalue is here, second eigenvalue is my here. Then what are the trace of the A square? So how you can find the trace of A square? You can find this 1 plus 5 plus 2 root 5 over 4, 1 plus 5 minus 2 root 5 over 4. Now you can find the trace, you can add them. 4 is LCM, 6 plus 6, 2 will be cancelled out, 12 over 4, 3. No, where is the mistake? Sorry, it's a minus B. It's a 3. It's a 3. So it's a 3, 3, 3, it's a 6, 3, it's a 6. So this will be cancelled out. So it's a 8 plus 8, 16 over 4. That's a, where is the mistake again? B square minus 4AC, 3 plus minus root 5. So B plus minus 4, A square plus B square plus 2AB, A square, sorry, A square is a 9. A square is 9, it is 9. So what is that? It's a 14 over 4 plus 14 over 4. So 28 by 4, 7 is the right answer. Okay, number of the linearly independent Eigen's vector. That is a sum of the geometric multiplicity. Similar kind of the question we discussed in the part 1 as well. You can see how you can find the geometric multiplicity. You can see this is the diagonal, this is a Jordan form. You can find the eigenvalues of this. Trace will be 3, determinant will be 2 minus 4 here. What as dot, this is because the upper triangular matrix are here. So corresponding to this eigenvalue is 3, corresponding to this eigenvalue 4. You can't factor them, so I can write this as here 9 plus 8 by 2. So it's 3 plus root 17 by 2, 3 minus root 17 by 2, and the other eigenvalues are my here. So they are the distinct eigenvalue. Once is a distinct eigenvalue, so algebraic multiplicity and geometric multiplicity are same. It is 1. So what is the sum of the geometric multiplicity? Corresponding to the each eigenvalue, geometric multiplicity is 1. So the right answer is 1 plus 1 plus 1. That is 4 is the right answer. Again, you can see here the number of the linearly independent eigenvectors. So again, you have to find the sum of geometric multiplicity of this. This is a 3 cross 3 singular matrix. What is the meaning of the singular matrix? Determinant is 0. So one of the eigenvalues is 0. Other two are my here. We need a m cube. So what is the eigenvalue of the m cube? Here. Then you have to write the m cube plus 2m plus i3. What is the eigenvalues of this? M cube 27 plus 6. 27 plus 6 plus 1. This is the first eigenvalue. This is 8 plus 4 plus 1 and 0 plus 0 plus 1. Clearly says that what is the answer of this? 34. It is 13. It's a 1. You can see they are distinct. Once they are distinct, so the answer is my 3. 1 plus 1 plus 1. Okay. A is n cross. What is the size of the n? It is not given. So I can simply take 2 by 2. Do you know any of the matrix whose A square is A? That's very simple. A is I. So what is the meaning of the A? 1, 1, 0, 0. So what is the trace of this? So clearly say the rank of A is my 2. What is the A trace of this? It is 2. So this is satisfied. Eigen's values are either 0 or 1. It's also OR. So it means what are Eigen's values of this? 1 and 1. So this is also satisfied. How becomes a 0? So if I write the characteristics equation, clearly say that eigenvalues are 0 or and 1. This is 0 and 1, but here is a OR. So one of the eigenvalues also be 1. So this option also cancel. Rank of I minus A. So if I find the I minus A, what is the answer of this? I minus this is 0, 0, 0, 0. What is the rank of this? It's a 0. Trace is also be 0. So that's also the right answer. A is a diagonal matrix with entries 0 or 1. Remember, it's a diagonal. What is the meaning of that diagonal is? They have the sum values, other are 0. But you can see A, I, they have the values are there. So either a 1 or 0. So it could be not possible because if I consider this value here, if I consider this is my A, what are the eigenvalues of this? 0 and 1. So clearly say that this option is not the correct option. So A, B and C are the correct options. Again, this is the eigenvectors. Whenever there is eigenvector, as I told you, you have to write Ax is lambda x. Let's say this one. If I try to multiply this by 1 of minus 1, what is the answer is? Minus 4 plus 5 minus 4. Can you written in the terms of 1 and minus 1? Yes, 4. So 4 is one of the eigenvalue. First part satisfied. I can take this as a 2 of 1. It is minus 8. Minus 8 is a minus 16. 10 plus 9, 19. Can you written in the terms of 2 of 1? No. So this option is cancelled out. Now let's start with 1 and minus 1. So 9 plus 7, 8 is 17. 5 plus 4, 9. It can never be written in the form of 1 minus 1. I can check here. Also you can check that trace 5. So you can see it's a 5. It's a 5. Determinant is a 4. 4. 4. So all are there. So 1 minus 1. So 2 minus 2 0. And 3 1 minus 3 minus 2, which is not equal to 1 of minus 1. Look about here. 1 of minus 1. 3 minus 2 1. 1 minus 2 minus 1. That's satisfied. Now I can check for the other pair. 2 of 1. What is that? It's a 6. 3, 2, 2, 1. So 6 plus 2, 8. 1, 2 plus 2, 4. I can return this as a 4, 2, 1, which is same. So this is the right answer of this problem. Okay, look about this one. So if these are the eigens vector of this, then what are the eigens values of this? Clearly says that again it is an eigen vector. So what is the meaning of that? I have to multiply this by here, then you will write in terms of this. So what is the answer of this? If you multiply them, 1 and minus 1, 0, 1, 0, it will be A minus 2, 3 minus of C. When it will be written in this form? Only when you taken as a 0, 0 times of this. So when it will be 0, when A will be 2, C will be 3. So the first answer is A. A2 not cancel. A2 are there. C will be 3. This is C. This is C. So both options cancel here. Now look about the B. I can check for the second pair. Now I can multiply this 0, 1 and minus 1. So what will happen? 0, 3 minus 2, 1, B minus C. I have to return in the terms of 0, 1, minus 1. This is possible only when B minus C is my minus 1. C is my 3. What will be my B? B will be my 2. But here B is my 4. This option is cancelled. Right answer is E. That is none of this is the correct answer. Okay, last question is there. 4 cross 4, M has the eigenvalues of this. So what are the eigenvalues of the M square? I can take as a square root of this. I need the eigenvalue of the M4. M square, again squaring them. 1 plus 5 plus minus 2 root 5 over 2. So that means, so 6, 3 plus minus root 5 over 2. What are the eigenvalues of the 8? Again squaring them. 9 plus 5 plus minus 6 root 5 over 4. So it's a 14, that's a 7 plus minus 3 root 5 over 2. This is the M4. I need a M square, that is my here. Now that's very simple. I, what is the eigenvalues of the I? 1, 1, 1. If I take 1 plus of this, it can never be of the 3. We need a 3 times root 5. When it will be 3 times? When you multiply this by 3. So this option cancel, this option cancel, this option cancel. Only this option is the right answer. So this is the way you can solve this eigenvalue problem in a very simple manner. I hope you can simply like, share and comment on this video. You can share with your friends. Best of luck students. Happy learning.